So basically I can find that the current is going like this. Can I say if the current is going like this must be the positive terminal, this must be the negative terminal. Basically I can take a consideration that this will be connected to the positive terminal of the cell, therefore this is at high potential, and this will be connected to the negative terminal, therefore this is at lower potential. Similarly this will be also there, this is high potential, this is lower potential. Assume that, remember what I have told you, that whenever you are taking any loop you have to take a path. Okay, so can I take, so hello everyone, good evening. I welcome you all to another lecture of our current electricity chapter, and we will be continuing the Kirchhoff law in this lecture. Okay, if you remember that in the last lecture we discussed about Kirchhoff current law, okay, which was known as the junction law, that the sum of the current at any junction is equal to 0. The incoming current will be negative and the outgoing current will be positive. That is our sign convention, and with the help of this we have solved around like a good number of questions. Okay, so let's have our discussion further. Okay, and today we'll be discussing about the second law, that is Kirchhoff's second law. Kirchhoff's second law, which will be known as Kirchhoff voltage law. This is a Kirchhoff voltage law. Okay, or you can say that this is the loop rule. Okay, so we got an idea. Now let us begin the topic. Okay, so if you get this thing very clearly, what is given to you, it's Kirchhoff voltage law and a loop rule. There is some relation of the voltage with the loop. That is the thing we are going to understand here. Okay, so what is it? Let's understand. The law says that the algebraic sum of change in potential around any closed loop is zero. Oh, what does it mean? Well, if you remember what was the equation I have given you in Kirchhoff current law. In Kirchhoff current law I have given summation of I is equal to 0. In this rule you will get that summation of delta V is 0. Remember, summation of V is not 0, summation of delta V is 0. Okay, for a closed loop. This is our main criterion, that it is for a closed loop. Okay, what does it mean? Let us understand it very carefully. Okay, let's say that there is a particular wire. Okay, this is a circuit. The circuit is ABCD. Okay, so it is said that when you will be taking about a closed loop, you have to make a loop yourself. Okay, you can identify that this is a loop and this is definitely a closed loop. Okay, you will find that in this particular case the summation of delta V is equal to 0. Now, okay, what actually does it mean? Let me draw it again and see this carefully. Okay, this is A, B, B, and this is C. Can I say that here the value of the potential will be VB minus VA, final minus initial, if I am going like this? Okay, you have to go in a particular fashion. Okay, let's say that in this loop I am going like this. If this is a loop, so definitely either I will be going clockwise or I will be going anti-clockwise. For this moment you can see that I am going in a clockwise fashion, so there will be final minus initial potential. Therefore for this point I can say, for this particular section it's VB minus A. For this you will go like this. Okay, from B to C, so here you will say VC minus VB. Here you will say that you are going from C to D, therefore VD minus VC. And here you are going from D to A. Okay, it is a closed loop, therefore you have to complete it, so you have to go back to A. So I will say that here it will be VA minus VD. Okay, you will find that the summation of all the potential difference is VB minus VA plus VC minus VB plus VD minus VC plus VA minus VD is equal to 0. You can have a check on this. See, VB gets cancelled, this was G. VB gets cancelled, VA gets cancelled, VC gets cancelled, VD gets cancelled. What I can finally from here, that the summation of the net potential difference, the change in potential difference, is equal to 0. Let me give you one more thing. You can identify this if I am going in a closed loop, so definitely I am starting from A, and if it is a closed loop, I am saying that I am finally there back to A only, right? So what is my initial potential? It's VA, and what is my final potential? It's again VA. So VA minus VA, that would be 0 only. That is the thing you have to identify from here. Okay, what is it? It says, hear me out carefully, it says that the change in potential around a loop is equal to 0. You might be thinking why I am stressing this many times on this particular statement. You will be knowing this when you will be doing the question. Okay, so for now I hope you understood this. Okay, so Kirchhoff current law was based on conservation of charges. Okay, you will find that this law is based on conservation of energy. This is an assertion region based statement for you, that Kirchhoff voltage law is based on conservation of energy. And what is Kirchhoff current law based on? It's based on conservation of charges. Okay, you can, if I say that it is based on conservation of energy, can I demonstrate it like this? Yeah, I can demonstrate. If this is your, again, the loop, okay, you are going, let's say, like this, so you'll be saying that change in potential is equal to what? Can I say that, let's say, basically I know work is equal to charge into delta V, right? Okay, so I can say here that it's summation of work upon Q. Well, basically I am going in a closed loop. What is the work done? What is the work done by the electric field in a closed loop? In a closed loop, remember, it's zero. Why it's zero? Because it is a conservative force. Electric force is a conservative force. Therefore, I will find here that the work done along a closed path is equal to zero. Right? Along a closed path, that was zero. The same thing has been applied here. Therefore, since work done is zero, I can say that change in potential is equal to zero in this particular case. Is that clear, everyone? Okay, so what it's based on? It's based on conservation of energy. Okay, I got it. So this was the initial important part that you have to learn. What is the second important thing that you have to learn? You have to learn about the potential gain or the potential drop. Potential gain or the potential drop. And the potential drop. Let's understand what is potential gain and what is potential drop. Okay. Again, I am discussing this thing for a closed path. Okay, that's a mandatory thing. Okay. Just assume. Okay. Tell me that if you are going. Okay. Just assume that you are there going from the top of a hill. Okay. Basically, understand that if you are there down somewhere. If you are going to a higher position, will you gain some potential energy, or will you gain some potential, or will you lose some potential? If you are going from lower to a higher position, definitely you will gain. Okay. Similarly, just because you are gaining some potential energy, what is the potential energy you are gaining? That's mgh. Remember, it's mgh. So I am saying that it's mgh. Okay. Particularly, I understand this, that this is mgh. Now, similarly, when you will go from higher to the lower position, you will find that I am losing some potential. I am losing the potential energy. I am losing the potential of energy. So that's the same thing here. Okay, remember. So when you go from higher potential to lower potential, that is what? That is potential drop. You will say potential drop has taken place. What does potential drop means? Delta V is negative. Potential drop is delta V is negative. Fine. Vice versa, if I am going from lower potential to higher potential, I will say that potential has been gained. Potential has been gained. Okay, and what's the value of delta V? Delta V is positive in this case. Okay, I hope you got this. So when you go from high to low potential, potential will be dropped, and when you go from lower to high potential, you will find that the potential has been gained. Therefore, delta V is positive. Okay, let's understand this more clearly. Okay, so let's say I will be talking about two things. Okay, I will be talking for resistors and I will be talking for cell. Let's understand this. Okay, let's say that this is a cell. This is a resistor. This is another resistor. Similarly, this is one and this is another one. Okay, perfect. Understand that this is the direction of current here, and understand this is the direction of current here. Okay, mind my words very carefully. So basically, I can find that the current is going like this. Can I say if the current is going like this must be the positive terminal, this must be the negative terminal. Basically, I can take a consideration that this will be connected to the positive terminal of the cell, therefore this is at high potential, and this will be connected to the negative terminal, therefore this is at lower potential. Similarly, this will be also there. This is high potential, this is lower potential. Assume that, remember what I have told you, that whenever you are taking any loop, you have to take a path. Okay, so can I take my path here like this? This is my path. Can I say that here I am going from the where I am going from where to where? I am going from the higher potential to the lower potential. I am not talking about the current. I am talking about myself, that I have chosen a path. I have chosen a path which is going from higher terminal to negative, which is going from higher potential to the lower potential. Therefore, for here I can say that delta V is how much? Delta V is positive. No, it's negative. Whenever you go from high to low, it's negative. Potential has been dropped. So remember, when you are going along the current, delta V is negative. Okay, remember, along the current, delta V is negative. Believe me, after a while you will be understanding what I am teaching this for. Okay, for now just believe that I am teaching you necessary things and understand it carefully. Okay, so whenever you are going along the current, okay, your potential will be dropped. Here take that you are going like this. So when you are going like this from high potential to the lower potential, okay, you will find that delta V is equal to positive. Okay, why it is positive? Because I am going from the lower terminal, lower potential, to the high terminal of the high potential. Okay, so therefore I will say that opposite to current, delta V is positive. Opposite to the current, you will find that delta V is positive. I hope you got this. Is there any difficulty, anything that you have not understood by this time? Okay, I hope you got this. Okay, so that was it about the resist. I will be discussing the application, don't worry for it. Now let us discuss about the cell. So these are the cells given to you. Okay, let us again understand that for now what I am doing, let us say that definitely this is my positive, this is my negative, this is my positive, this is my negative terminal respectively. Okay, now again remember that if I am going like this, if this is my path, this is my direction of consideration, this is the way I am going, this is my path, so I will say here that when I am going from the higher terminal to the lower terminal, the change in potential will be equal to negative E, right? And for this one, if I am taking the path like this is my path, so I will find that change in potential is equal to positive. Okay,
Problem is not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.